Hello, in this video I'm going to tell you some interesting facts about Python and some differences that Python has from other languages like C. So let's see, in C programming language, when we about C language, like I suppose I write int x is equals to 10. So this means that there is a variable x. I've created a variable x, and this x has been assigned some address. So this x has been assigned some address, and this address contains a value of 10. So you can think of x as a bucket, and this bucket holds a value of 10, and this bucket has an address. But when I talk about Python, so in Python things are different. So in Python, when I write x is equals to 10, and remember that in Python we do not write uh, we don't write int or string before this. So here x is just a name. I won't call it as a variable. I will say that it's just a name which has been binded to a value of 10. So this 10 is actually object. So in Python everything exists as an object. So this 10 is actually an object, and it is also being allotted a address. So this 10 is an object and it has an address in the memory, and this x is just a name which has been binded to this object. So if I write that x equals to 20, does it mean that 10 is deleted? So does it mean that 10 is deleted? No, 10 is still there. So 10 is still there because it's an object. All right, but we have created another object as 20, and this x which was referring to 10 was which was earlier referring to or binded to 10 it will not be referring to 10, it will be referring to 20. All right, so only the binding or the referencing has changed, but the object is still there. But in C programming, if we would have written x equals to 20, then things would have been different. Then entire bucket would have changed. The 10 would have been removed and 20 would have placed. So there is no 10 here, there is only 20. There is no 10 here and there is only 20. But in Python, 10 will also exist and 20 will exist, but only the referencing will be changed. So if I come back to the program, and if I say that print new node, then what do you think the output should be? So should it print the node, and should it print everything inside that node? Like, remember that when we create a node, so this node actually contains data, and it also has next. All right, so it has data and next. So do you think that when I print new node, will this entire node be printed? uh, let's see. So if I just print node here, so we'll see what gets printed. So, and also I will print a break here. All right, so remember that here we are pushing using the function push, and we have used the function push 4 times, which means there will be 4 print, and following print there will be a blank line. So let's run it. So see, since we have used 4 push operations here, so 4 prints are there. All right, so we have used 5 push operations: 1, 2, 3, 4, 5, and so there are 5 print and 5 blank spaces, blank lines here. So we see that main.node object at this. So when we print new node, we see that so this is it. When we print new node, and the first time we use the push operation, push 1, so like this. So the first time when we pushed and used push 1, so this is the location at which the node is created. All right, so when we do this print node here, so when we print the node, then the node, the printing of the node will actually return an address towards it is bind to which it is binded to. So like I said in my previous I just said few seconds earlier that x is equals to 10, which means x is binded to 10. X is just a name. X is just a name which is binded to the value of 10. Similarly here, new node is just a name which is binded to node. All right, and when I say print new node, then it will print the memory of that binded location. All right, so new node is binded to node, and it will print the memory at which memory location at which the node is present. Similarly, when I do push 2, so this is similar to like x is equals to 20. So when I do x equals 20, so a new object is created having 20, and this x, which was earlier referencing to 10, will now refer to 20, and which means this 20 has a new address. This 10 had a different address than 20. So this address and this address will be different. So similarly, when I again use push operation to push 2, then a new node is created, and that new node will be having a new address. And when I again do when again this print operation runs, then it's gonna return a new memory location. Right, this is again gonna renew, it's gonna return a new memory location. This is also new, and this is also new. So like you can see that this is the concept of Python, and uh, we're gonna use this object-oriented concept in all our videos. Like in my next videos to come, I will be talking about deletion. So when I will be talking about deletion, then just to give you a foresight of the future, then I would say that there is a node which is to be deleted, and this node is attached to this node, and this node is actually referencing to some other node. And suppose we have to delete this node, then this node, this is the next, and next. So this next is just a name which is binding to some node. All right, it's just name which is referencing or binding to some node. So in order to delete this node, we can simply change this referencing. All right, so not this referencing, we will simply change this referencing. All right, so we will say that if we are we don't want to reference this node with this node, we'll say that we will reference this node directly with this node. But for referencing this node directly with this node, we have to get the reference of this node from this node. Right, don't get confused. First, what we'll do, see, first we will get the reference of this node from this node. All right, so the reference is this, so reference is next, so reference, so this next actually references to this node, so reference we'll get from next. So suppose this is node, some node, so we'll take node dot next, and we'll simply pass this reference to this node, and we will say this nodes, so I will call this node 1 dot next, and I will call this no, I will call this node as node 2 dot next is equals to node 2 dot next. So by changing this binding, we can we can directly link this node with this node. So we only change the referring, that this node's next is equal to this node's next, and this node will automatically get deleted when during runtime. Python will automatically eliminate this node because it is not being binded, and this error which was present, it showed binding. Now this error will not be present because this node is not binded to this node. So this node is, oops, so this node is not binded to this node, but this node is binded to this node. All right,